Hello everyone. In this video we're going to be looking at telemetry, and in particular telemetry sensors, and how do we go about connecting a number of telemetry sensors onto the bus system that's applicable to the PowerBox radio system. So for this example video we'll be using two PBR26D serial bus receivers as well as a Mercury SR2. Now, if you watched my one of my previous videos on the Mercury SR2, the basic connectivity, you'll note that receivers connect to the Mercury via the P2 bus or the P2 bus, and that's its primary connection to and from the receivers. And you'll also be aware that the Mercury itself sends telemetry back out on one of these cables. So the RX1 cable is connected to this receiver here. So the telemetry from the Mercury is sent out via this cable into this receiver, and then the receiver sends it back to my core transmitter. Now, the P2 bus or the P2 bus. This particular bus is quite a bit different from a lot of other RC manufacturers. One of the reasons being is PowerBox, when they designed their radio system, they didn't have their hands tied. They didn't have to make this particular bus compatible with older systems. So they started afresh. So they designed the bus with quite a lot of capability. And just to give you an idea, so let's recall what the bus actually handles as far as what data travels along this bus. So we all know that telemetry travels along this bus, and also our servo information. So remember, all 26 channels, say from my core, are being received by one of these or both of these receivers, and that same data is then transmitted out along that same bus. So this receiver here is handling telemetry from the Mercury, but it's also sending out 26 channels worth of servo data towards the Mercury so I can decode it and drive my servos. One other bit of data that most people will seem to forget is the P2 bus also handles all the programming information when we program a device remotely from the transmitter. So for instance, with the PowerBox core, it comes with a little OLED display. I currently don't have it connected. However, I can program a lot of the parameters, or the majority of parameters can be directly controlled from the screen on my PowerBox transmitter. And that information that's sent to the Mercury, and then the Mercury has to respond back to say a value's been accepted, etc. That's all done by the same bus. So really there's three key components to the bus. There's the telemetry, there's the servo information, and then there's the programming data for whatever device is being programmed along the same bus. Now, when PowerBox designed this bus, they designed it to be extremely high speed. So just to give you an idea, the bus can handle 800 telemetry values per second. So that's quite a few values per second. Not only that, is those values are all 16-bit. So a lot of bus systems on a lot of other older systems, or pretty much all the other RC systems, are not 16-bit. So they have limitations in regards to how much data they can throughput on the bus. And being a true bus system, so this bus is truly bidirectional. A lot of other systems don't feature a true bidirectional bus. So there's limitations there when it comes to programming devices, etc. And also the number of sensors that can be addressed on this bus is a lot higher than most other systems. So for instance, with PowerBox, the P2 bus itself can address up to 250 individual sensors. And each one of those sensors can output 32 values of data. So for instance, if we have, say, a voltage sensor, the voltage sensor normally only senses voltage, so it will have just one value, being voltage. However, if we had, say, another sensor, say this PowerBox Mercury, for instance, sends telemetry back into the system, I think it's got something like about, it can have up to, a dozen or so different variables that it can send back. So it's just one sensor. However, it can have up to 32 values that it can send back. So that's 32 individual parameters, if you like, that it can send back along this bus. And don't forget, all those sensors can transmit 800 telemetry values per second. And later on I'll explain how that feature of this high-speed bus, which is the highest available in the RC market at the moment, how that can come in handy when we're measuring things like a voltage drop on an aircraft when we're doing some diagnosis as far as a fault condition may occur. Okay, one last thing before I leave the P2 bus technical stuff is at the moment you'll notice we've only got a short run here for this bus. It's maybe what, 30 centimeters if that. However, PowerBox being pretty clever, they designed this bus to work over multiple meters. So for instance, if you had a really large aircraft and you might have this receiver connected right at the back of the aircraft, it might be say 4 or 5 meters away, not a problem. There's no need to have any sort of amplifier in series or signal conditioning devices or anything. The bus can handle it. So again, long cable runs as far as the P2 bus is concerned is not an issue. One other thing is, I know for instance some of the other brands of radios, when you connect multiple sensors, you might find you connect a couple of sensors and then you have to pull a few stunts like basically put in another device that gives you like an expansion module to give you more sensors. Not so with the P2 bus. The P2 bus is a lot more flexible. All you need is basically a bunch of Y cables or the facility to make more ports available without any electronics. And for instance, I do have a device here somewhere on my table. Let me look for it. Here it is. So I have this device here called the PBS dock. Now the PBS dock doesn't have any electronics in it, but what it does do is it allows me to plug this into, say, the P2 bus, and it gives me 5 outputs. And this is really handy if you've got multiple telemetry sensors. So just think of it as a Y lead, but instead of having 2 outputs, it gives us 5 outputs. And if you had 2 of these, for instance, you could plug a second PBS dock into, say, one of these ports, and that'll give you also 5 outputs, and you can basically fan it out from there. Remember, the limit is 250 sensors, so there's 250 sensors you can set up on the P2 bus. Most people just would not even get remotely close to that number of sensors, but it does show you the capability of this particular bus system. It's really miles ahead of any other RC manufacturer. Anyway, let's talk a bit more about the sensors themselves. So for this video, I'm going to be using a voltage sensor called a V60. So these are just some spare sensors that I've purchased over a bit of time, ready for some aircraft. I haven't installed these, so they're just sitting in my spares box at the moment. I also have a PBS T250. So this looks similar to the PBS dock that I just showed you, but it's totally different. So this device here is a temperature sensor. So this one does actually have a little micro in here. There's a bit of electronics in here. And what it does is it allows you to plug in thermistors into these ports. So it can handle up to 5 thermistors. And basically it can read up to 5 individual temperature sensors. So you can see here we've got some thermistors here. I think they're 10K thermistors. I'm not 100% sure. These are the factory PowerBox ones. And I've got 3 here because I've got a Sato 3-cylinder 4-stroke in one of my Warbirds that I want to set this sensor up to. I currently haven't done that, but that's why I purchased this sensor. So we'll use this in our video today as well. A couple of other sensors. So I also have a few jets. With jets, I have air pressure systems in a couple of these jets. So we have some sensors here. So we've got the PBS P16. So this is an air pressure sensor, and I've got 2 of these sensors because I've got a couple of jets. I haven't installed these yet. So the reason that I'm going to use 2 of these sensors in this video is going back to the addressing on the bus. I'll show you how to change the address of one of these sensors so there's no conflict. So normally when you purchase one of these sensors, it comes set to its default address. So all these sensors have a default address. You hook it up to the system, you don't have to worry about the address information as far as normal use is concerned. The only time you have to be mindful of the addresses is when you have 2 of the same sensor. So in this example, we'll be using 2 of the same sensor, being these 2 sensors here. Currently both of the addresses are the same, and I'll show you how do we change the address of one so it allows us to connect the second sensor without any address conflict on the bus. Okay, so let's clear up my little table here. Actually, before I forget, I'm going to use one more sensor. So I want to cover the GPS-3 a little bit. So this is a bit of a special sensor insofar as the GPS-3, as showed you in one of my previous videos, can be connected directly to the P2 bus. However, in a lot of cases where we want speed compensation from the actual system, we connect it to the fast track port of the device in use. So for instance, in this example, we're using a PowerBox Mercury. There's a fast track port. So what I want to do is show you how, when we connect the GPS, I should say, is when we connect it to the fast track port, how it appears in the telemetry screen versus when we connect it direct to one of these receivers using the P2 bus. Because there is a little bit of difference there, and I just want to highlight that to users. A lot of people get tripped up by that for some reason. Okay, so let's just leave the voltage sensor as our first sensor, because this is a simple sensor. It only has one value, being voltage. So it'll just be easy to sort of think about when I do the example. Now, we need to connect that to the P2 bus. So we have a couple of options here. We have receiver 1 and receiver 2, because don't forget, the telemetry basically comes out of the sensor. It doesn't really go back to the Mercury. The Mercury doesn't really care about this sensor. It doesn't address it or talk to it in any way. However, the receivers do. So we can actually simply attach the output from this sensor to any one of these P2 bus lines. It doesn't matter. Another unique property with PowerBox is the fact that any receiver can be used as a telemetry input. The majority of other systems can only handle one receiver handling the telemetry. That's not a limitation for PowerBox. PowerBox, if I had 4 receivers bound to my core, all 4 receivers are transmitting telemetry back to the core simultaneously. So the sensor can be connected to any receiver that features a P2 bus line. It doesn't care. Simple as that. So don't be scared. Say, for instance, this receiver was connected to the nose, and this one, say, might be in the middle of the aircraft, and this sensor, say, up in the nose, say, where my batteries are. You might find it's just a lot easier just to run a short length of cable. Maybe this individual cable will reach this particular receiver. Go ahead, connect it to the P2 bus, and you'll have telemetry. The system does not care which receiver it's plugged into, because remember, all it's looking for is the unique addresses that these sensors are given. So it's irrespective of whether it's connected to this receiver or that receiver, the system does not care. Performance is exactly the same. It does not impact performance in any way. Okay, so let's just connect it to the P2 bus on this receiver. And I'm just going to use the standard Y lead. So I've got a Y lead here. Let me plug it in. And I'll just connect it back to the Mercury first, so we get power to the receiver. There we go. So the receiver's connected back to the system. And now I'll just plug in the sensor. Just plug it in. And away you go. That's it. We now have this voltage sensor connected to the system. Now we're not going to get much further as far as excitement is on this screen. So I'm going to move over to the core. So I'll just set up my camera looking at the core screen, and we'll have a look at setting up this sensor and see what it looks like. So what I'll do is I'll just switch off the receivers, and let's move over to the core display. Okay, we're now looking at the screen on my core, and I've just basically chosen this particular model. I currently have the actual test jig switched off, and you can see there's no telemetry being received by the core transmitter. Now, I want you to pay attention to a message that will pop up when I first turn on our test model. So let me go ahead and switch it on. You'll notice the telemetry icons have just popped up. And you'll notice a message pops up that says 4 sensors found. And you think, Well, hang on, we've only got the one telemetry sensor connected, that voltage sensor. Why is it indicating 4 sensors? Now remember when I was talking about the P2 bus, how it handles sensors and that? So any device that's basically connected to the system is classed as a sensor as far as the bus is concerned. So let's take a closer look. So let's make a telemetry widget. So let's make a widget over here. Let's go into the telemetry screen, and you notice we've got an option to have a look at sensors. So we just hit the positive symbol. And you'll notice under our sensor list, we have items such as the 2 receivers. So we've got PBR26D. So this first one is bound in slot A, then we've got the other one bound in slot B. We have the core itself, the transmitter. Then we have our voltage sensor, the PBS V60, and then the Mercury SR2 as well. So these appear as sensors as far as the bus system is concerned. Now just be aware that the core is a bit unique insofar as the core, the transmitter itself, is not connected to the P2 bus. However, the other ones are. So if we count the actual sensors, we've got the 2 receivers, so that's 1, 2. We've got the voltage telemetry sensor, 3. And then we've got the Mercury SR2, which is 4. So that's a total of 4 sensors. So when we switch on the model, and you first go into a model memory, the system automatically scans for the sensors. And that's why it indicates that it's found 4 sensors, because there are actually 4 sensors. So don't forget, these 2 receivers can send back telemetry, so things like RSSI, link quality, etc., etc. The voltage sensor, of course, can send back voltage parameters, and then the Mercury SR2 has its own sensor information as well. So for instance, if I click on the SR2, oops, just get it on the screen there, you notice there's a whole lot of parameters it can send back to the core. So for instance, holds, lost frames, antenna fades, the current drawn from the system, battery capacity, can calculate battery capacity, the regulated voltage output, the battery input battery voltage, etc., etc. And same goes for all the other sensors. If we pick the voltage sensor, it only has one parameter, and that's voltage. So let's make a couple of widgets. So let's make a widget for the first receiver, and let's pick on, say, RSSI 1. And click on OK. I'll make another widget for the second receiver. So this is pretty basic stuff. Let's make it RSSI 2. So we've got a 1 and 2 there to differentiate between the 2 receivers, even though it does say A and B in there. And let's make one for the voltage sensor. So the PBS V60. We'll select voltage. That's the only thing we can select. And then let's have one for the Mercury as well. So Mercury SR2. Let's say look at status for that. So there we go, we've got a couple of telemetry widgets. Nice and simple. Now remember we were talking about addresses, how each one of these devices, so the voltage sensor, the Mercury itself and the 2 receivers, they're treated as individual sensors. So each one of these devices is assigned a unique address. So if you want to have a look at the address, all you need to do is go back into the menu, the telemetry menu, and once you're presented with this screen, all you need to do is long press, say, on the sensor name, and you'll notice an address value pops up. So the receiver that's bound in slot A on my core is assigned address 0. So click on OK. Let's have a look at number 2. Same thing, long press on the sensor name. It's address 1. So the first receiver's been assigned address 0. Second one's been assigned address 1. They're both unique. Let's have a look at the voltage sensor. Again, long press. This one's been assigned address 41. So that's actually the default address for a voltage sensor. So when you purchase one in a packet from your dealer, it'll come preset to address 41. And we can actually change that, and I'll show you later with my pressure sensors how we do that. It's pretty easy. Basically, we have a look in here. But for now, we'll just move on. And same goes for the Mercury. So the actual Mercury unit itself is assigned an address. And there you go, address 47. So remember, the voltage sensor is 41, the mercury is set to 47. So that's the default address for a Mercury SR2 is 47. Again, we can change that if need be. Now normally when you set up sensors in your aircraft and you have just one sensor of any one type, you don't have to worry about the addresses because the default addresses are preset, so they're all different or unique if you like. The receivers are a little bit special insofar as the system can auto-assign addresses. So if I swap my two receivers around, so if I bind this one into slot A and that one into B, you find the addresses will automatically be assigned. So you don't have to worry about it as far as receivers are concerned. It's the only time you really need to be aware of it is when you're using two of the same type of telemetry sensors. Otherwise, it's an issue you don't have to worry about. So now, remember I said that when we first switched the system on, it did that auto scan. So the system has the facility to auto scan. And the only time it does that is if you select the model. So for instance, actually just before I explain that, if we switch the current model off, so I'll turn it off, you'll notice our two telemetry antenna widgets, or basically icons, have lost their little, I don't know, range indicators, whatever you like, or signal strength, relative signal strength indication. They've disappeared, and all our telemetry values are flashing, indicating the system cannot receive telemetry. Now let's turn the unit back on and watch what happens. So we switch the unit back on and instantly we just get the telemetry values being sent back to the core radio. However, you'll notice there's no message that popped up saying there's 4 sensors found, and that's because the system only automatically scans for sensors if we have selected this model being a new model. If we select the model or switch on the transmitter, it only does it once right at the beginning. So just to give you another example, let's switch it off. We've lost all our values, switch it back on, we get our values back, the system's working. However, there's no indication that the system has automatically scanned for the sensors. Now normally when you're flying, it doesn't need to auto scan for the sensors, just that say on your when you first switch your transmitter on, it will do an auto scan, and then when you shut down the transmitter, switch it back on again for that model, it'll do an auto scan again. However, if you just turn the model off and then back on again, it will not do an auto scan. And some people get caught out on this, especially when they're working in their garage and they're playing around with the sensors and whatever. They change the sensor configuration, but the system, because it's not auto updating, it won't actually detect the new sensors, and people scratch their heads and post up on the forum, hey, the system can't find my sensor, sensor's faulty, blah, blah, blah. But in reality, it hasn't been picked up. Now, the system does offer you the feature of doing a manual scan. And all you need to do is go into one of the telemetry widgets and just hit rescan sensors. And the system will do an automatic or a manual scan in this instance, and it will scan for any new sensors or any new reconfiguration of the sensors. So usually when you're playing around in your garage, that comes in handy. If you plug in a new sensor or remove a sensor, you really want to hit this before you go programming up the sensors. Just to give you one more example, let's turn the unit off, or turn the mercury off, I should say. So it's currently off. Let's go, say, into another model. So there's another one of my test models. So we'll quickly select another model memory, I should say. And then say we're going to fly this test setup that we've got, which is just called new. So I'll load that back in. I don't have any image associated with it. That'll just quickly load. Let's go back to the home screen. So we get our current screen, and you notice there's no values in place and there's no flashing because we've just loaded this new model. Now let's see what happens when I now switch on my model. So just apply power, and you'll see the telemetry indicators here show a signal. Then after a few seconds, you'll notice the system has auto scanned. So just be aware, whenever you load a new model or come in from reload the model, I should say, the system will always auto scan. However, if we now just turn off the model, Let's turn it off and switch it back on. The system will not do an auto scan. However, you do have the option of manually rescanning. So just to remember, if you're playing around in your garage, fiddling around with the sensors and plugging in sensors, removing them, adding them, etc., it's handy to always go in and do a rescan when you want to address the sensors. So it's just as simple as touching that, waiting a couple of seconds. The system will go out, interrogate the receivers and all the sensors on board the aircraft, and that's it, done. Okay, now one other thing, getting back to the performance of the P2 bus. So we have a voltage sensor here. I just want to state this because for me this was quite an important feature actually, and one of the reasons I chose PowerBox System over all the other systems that are currently available. I don't have a variable power supply connected, but what I have noticed when fiddling around with, say, the voltage sensor, I have hooked it up to a variable power supply in the past, and I can vary, say, the power on my power supply using an adjustable knob, and I've just happened to notice that the response rate on the core is pretty fast. It's extremely fast actually. It's a lot faster than all the other systems that I've played around with, and that's again back to the capability of the P2 bus or the P2 bus. Remember the fact that it can handle 800 telemetry values per second, which is extremely quick compared to other systems. So that translates out to, for instance, when we're looking at, say, voltage on our aircraft, remember we can actually record a minimum and maximum with these. At the moment, obviously, I don't have a power supply connected, so it's just got 0 volts. So when you go for a fly and land, you'll get a minimum and maximum. Some other systems feature a similar function where they can record minimum and maximums. However, their telemetry speed is a lot slower. So if you get a very short duration, say, dip in your voltage, in a lot of other systems that goes past undetected and you're none the wiser. The telemetry just cannot pick it up because of the slower speed that's available on the other systems. However, with PowerBox, the fact that it can work so fast, those voltage dips can be picked up. And I've actually compared it to one of my Fluke 189 digital multimeters, which is a high performance meter, handheld meter. That's got like a 1 millisecond peak hold capture. And it's actually very close to that. So I would estimate that the capabilities of this system, can pick up voltage dips in the low millisecond, 1 to 2, 3 millisecond range. On a lot of other systems, you're talking hundreds of milliseconds, and they're just too slow. They're just too slow in regards to picking up a voltage transient. And yeah, I mean, you can record all the telemetry you like, but those transients will go undetected. However, if you review the data on a PowerBox core system, you will pick up those transients, and it goes a long way to basically improving your telemetry capabilities and the fact that you'll be able to capture those, say, low voltage spikes or drops in voltage compared to other systems. So it really helps out with diagnosis. So I just wanted to put that in because for me that's, I have an electronics background, so for me that was sort of an important point, and that again was one of the main reasons I went for the PowerBox system. The telemetry features on the P2 bus quite exemplary compared to other systems. Okay, now I'll move back. We'll have a bit of a play with some more sensors. So I'll go away from the core screen and we'll move back to the test bed. So give us 2 seconds and I'll just switch camera positions. Okay, we're back to our current test bed. Now I'm going to let's connect the thermistors or the temperature sensors. So we've got the PBS T250 here. So remember we've got 3 temperature sensors plugged into the unit, so A, B and C on here. And we'll use that to measure some temperature. So we're just going to measure the temperature, ambient temperature of my garage. So I'll just leave those just bound up as they are. Now, we need to connect this sensor up to the P2 bus. So I don't have any more spare ports on my wire lead. So what we're going to do is we're going to invoke this little PBS dock. So this is a little handy box. Again, There's no electronics in here, but it does give us 5 outputs. So just think of it as a 5-way Y lead. And let's connect it to the second receiver. So remember how I mentioned earlier, the system does not care which P2 bus line we use. As long as it's P2 bus, it'll work. So we'll just hook it up into the second receiver, and this leads from the Mercury itself. So let's plug that into the PBS dock. So we'll just use port A. Each one of these ports is identical. We'll just stick that down. And now let's also connect the temperature sensor. So let's connect it to port, one of the other ports. If I just get the plug around the right way. Plug it in, I think that's plugged in correctly. Just use the port there. And we'll switch the unit back on. And again, we have the 2 green lights on the receivers, but there's no other indication of the system is working or not. So now we've got the PBS T250, the 5-way temperature sensor, or the 5-sensor temperature sensor connected to this receiver's P2 bus. And we still have the voltage sensor as well as the Mercury's telemetry feeding back through this receiver here. So remember, the system doesn't care which receiver we use for telemetry. You can use either, you can use both. The system is capable of handling telemetry return back to the core transmitter from any receiver. Okay, let's switch or move back over to this core screen. So I'll just switch our little model off, and we'll move back over to the core screen. Okay, now we're looking at my core's transmitter screen. And because we've switched on our little model, we don't have any telemetry as indicated by the lack of the little curved lines there, and also the telemetry values are flashing. Let's switch our model on, and we instantly get back our telemetry values, and you can see that the system's indicating strong telemetry signal strength via the little icons there. At the moment, remember, we've connected the temperature sensor up to the second receiver. However, we need to set up a widget for it. So let's set up a widget, say in the bottom left-hand corner here. Now remember that the system did not do an auto rescan of sensors, so just keep that in mind. So when we look at the telemetry here, because we only turned I didn't turn my core off or didn't change the models in my core, so I left the model still active, if you like, in the core, and all we did was turn the actual test model off and on. So when we go into the telemetry here and we look at the sensors, you notice we can see the receivers, the V60, which is our voltage sensor, and the Mercury. However, there's no temperature sensor. And you think, okay, the temperature sensor isn't working. Well, it's all due to the fact that we need to rescan the bus again. So all we need to do is go in here, rescan sensors, wait a second or two. It should now pick up the temperature sensor, and if we now have a look at the sensor list, lo and behold, we get the PBS 250 listed in the sensor list. So remember, this one's working off the second receiver on the P2 bus line of the second receiver. Again, just to reiterate, the system does not care where you connect the sensors. As long as they're connected to the P2 bus somewhere, it'll work. So let's select that sensor, and you'll notice we have a selection of values. We have the 5 thermistors basically. Now I've only got 3 thermistors connected to ports A, B and C. So let's select, say, port A, and let's have a look at the address of this sensor. And this one's 42. Now you may or may not remember, but the voltage sensor was 41. This one has a default address of 42, so it's unique. And I think the Mercury, what was it, 43 or 47 or something? We can actually go and have a quick look. Oops. Into the Mercury. Just a yeah, 47. So we've got those 3 devices. They've all got their unique address. Anyway, So down here we now have temperature A, which is the thermistor plugged into port A on the PBS T250, showing you 22 degrees. One other handy thing while we're here is if we go into the telemetry menu, we can add a couple of different other values. So let's go B, and you can even add a totally different sensor if you like as well to this widget. However, we'll just stick to the one, which is temperature. So this one widget is now going to show us the 3 temperatures, and what it'll do, it'll cycle through them. So we've got temperature A. If you wait a few seconds, it'll switch to temperature B. Wait a few more seconds, it switches to temperature C. So basically, if you don't want to use up 3 square blocks for display real estate, if you want to preserve the display real estate, you can have multiple values in the one widget. That's all I just wanted to show you there. So now we have not only the voltage sensor, we now also have the telemetry sensor for temperature connected to our system. And you can see how easy it was. It's just basically plug and play. There's no extra devices needed. There's no real special programming. The system is very flexible, but it's also very user-friendly. Okay, now I want to show you in regards to the addressing, what happens when we select or we want to use 2 sensors of the same type that have the same default address. How do we go about reprogramming the address? So let's move back to the model again. So we'll show you all the wires, etc. And we'll hook up the PBS P16, which is an air pressure sensor. Okay, let's go to that. Okay, we're back to viewing our little test model or our test subject. Now, let's have a look at the PBS P16. So I've got 2 of these. One is a slightly older unit. So it's got the standard yellow, orange and red and brown cabling, and the other one's got the more modern white, red and blue cabling. However, the sensors are effectively the same. But we've got 2 of them. So let's connect one of these up, and let's have a look at the default address after we connect it up to the P2 bus. So I'll just plug this into port B. So our first pressure sensor is connected to port B of the dock. So remember, this dock doesn't have any electronics, it's just really a 5-way splitter, and it's plugged into the P2 bus. So port A is basically a lead to the mercury, port B goes to our pressure sensor, and then port E goes off to our temperature sensor. So let's switch over to the core. Actually, one thing to be aware of when you're planning to using 2 of these sensors or 2 of the same sensors, connect the first sensor and then change the address on the first sensor before you connect the second sensor, because remember, these will both have the same address. So if you connect these 2 together at the exact same time with the same address, you'll cause conflicts of the bus and you'll get some weird results. So just connect one up, we'll have a look at its default address and we'll shift it. Okay, let's move over to the core screen. Okay, we're now back looking at my screen on the core, and you'll notice the current sensor information is being displayed. We don't have a pressure sensor. Remember, I plugged it in with the system being on, so we've reconfigured the system as far as the sensors is concerned. However, if we try and generate a new sensor, so let's go over here, let's make one for the pressure sensor. If we look in the sensor list, you'll notice that it doesn't appear because we need to rescan the system. So let's rescan sensors, wait a few seconds, and done. Let's have a look. So in the list now appears the PBS P16, and there's only one value associated with that, and that's pressure. So let's select that. Now remember, this sensor is currently set to its default address. Let's have a look at what it is, and you'll notice it's address 44. So in the current setup with our test bed, address 44 is a unique address, not a problem. The system will operate fine as it is. And we're obviously we haven't got any pressure connected to it, so it's just reading 0 bar. Now, remember we've got another PBS P16 pressure sensor, and I want to connect it to the system. So what do we need to do to shift the address? Because we know that the second sensor is going to have this same address. So if I go back in there again, oops, let's hold it down properly. We've got address 44. We want to shift it. So all we need to do is basically press on this little icon here. So the X dash greater than Y. So just press it once and wait a second or two. It should go out to the sensor and basically change its address. Let's have a look at its address now. You notice it's now set to address 200. So it was 44, it's now 200. So when we connect the second sensor, that'll have address, address 44, and basically it won't conflict with the two. Now, if you ever need to reset an address, it's not explained in the manual very well, but all you need to do is long press on this same button here. So if we long press on it and let it go, takes a second or two, and then let's have a look at the address again, and it's back to its default address of 44. Simple as that. So let's change the address, because that's what we want to do, because we're going to hook up the second sensor. Give it a second or two. Let's confirm. Yep, set to 200, back to 200 again. And you can keep on going. So if you had 3 of these sensors, or 4 or 5 or 6, you can just keep changing the address and it'll select the next free address. So you don't have to scroll through any addresses, or it's pretty much automatic. So now we've got this pressure sensor here, PBS P16 at 0 bar, and that is basically set to address 200. Now, I won't bother showing you this, but I'll connect the second pressure sensor up to the PBS dock. So I'll just plug it into the next available free port, which is port C on the dock. Okay, I've plugged the second pressure sensor in. So again, because the system is on and I've reconfigured it, we need to tell the system that we need to rescan the sensor. So let's set up a new widget, or go to set up a new widget. And we notice we've only got the one PBS P16 in there. And actually, just before we connect the new sensor, I might just change the name of it. So let's go back into here. It helps if I do it correctly. You can also change the name of the sensor. So let's call that, say, I don't know, let's make it _1. So that's our first one that I connected. It just makes it easier for us to reference it on the display. So you notice the name's now changed to PBS P16 _1. And you can change both, not only the sensor name, but its value as well. You can change it to whatever name you like. Let's go into this second widget here. Now remember, we've got P16 _1, which is the first sensor set to address 200. We don't have the second sensor appearing, and that's because we need to rescan the bus. So let's rescan the bus. Remember, you only need to rescan manually if you're ever doing any changes to the bus with the system being on, etc. So let's have a look now. And we'll notice there's a P16 in here. So this is the second sensor. So we've got P16 _1, and now we've got P16. And remember the default address, what was it, 44? Let's have a look. So this is the second sensor, and lo and behold, it's set to address 44. So the first sensor's been shifted to address 200. This one's 44. We can leave it in that. However, if we had a third sensor, again, all we need to do is shift, say, this sensor or the first sensor, doesn't really matter. We just quickly press that. And let's see what address it picks this time. There is a bit of logic as far as the address allocation is concerned. So you notice it's now gone to 201. And that's because the first sensor is set to address 200. So it's automatically detected that 200 is in use. So it's used the next free user assignable address, which is 201. And don't forget, if you want to reset it back to default, just long press on the same button and it should go back to 44. So let's double check, and there you go, address 44, simple as that. And again, just so you don't get confused with the sensors, we can rename this whole name here. However, let's keep to the standard format that I was using before, make that _2. So if we go OK, so our home screen shows us the two pressure sensor values. So one's from sensor _1, the other one's _2. If you ever need to make a new widget and you need to refer to those sensors, they now carry that name over into the sensor list. So we have a 16_2 and an _1. Simple as that. Okay, now that's pretty much it as far as the telemetry sensors is concerned. What I do want to cover, just as a final point in this video, is the GPS 3 connection. So if you remember in one of the earlier videos in basic connectivity for the Mercury SR2, the GPS is a little bit of a special sensor insofar as it's got a dual use connectivity. So for instance, if we connect it to the P2 bus as a straight telemetry sensor, it'll give us all the satellite information, longitude, latitude, speeds, all that sort of stuff. And it'll supply that as a standard telemetry value to the system. However, we can also use it to regulate the speed when we're using a gyro. So when we're using a gyro, the GPS can be used, or the GPS speed information can be used to regulate the gain of the gyro. And to do that, we need to connect the GPS 3 to the fast track port on the PowerBox unit, whether it be a PowerBox Mercury, a Pioneer, a Royal, or even the competition. It's the same connection. So let's have a look at that, because a lot of people get confused with that insofar as if you connect it to the fast track connection, the telemetry is sent back via, say in this case, it will be sent back via the Mercury. However, it's connected to the P2 bus, it's sent back via the receiver, and it appears differently on the core screen. So anyway, let's have a look, and we'll reconfigure the model. I'll just get rid of these other telemetry sensors so it doesn't confuse everyone, and we'll go back to a basic configuration just with the GPS. Okay, let's switch the camera back to the model. Okay, we're back to viewing our test setup. So you can see that I've removed all the telemetry sensors we were previously utilizing, and that's to keep everything simple so you can follow the example easily. Okay, GPS. I've got a GPS 3 here in my collection of sensors. So let's stick him down here and keep an eye on him. Now the GPS 3 is a bit of a special sensor insofar as it can be connected to two areas. So one of them is to connect it directly into the P2 bus as a typical telemetry sensor. And we'll do that right now. So I've got the wire lead that's connecting this receiver's P2 bus to the Mercury, and now we'll just hook up the GPS 3 as well. So the GPS 3 is now connected to the same wire lead that plugs straight into the P2 bus. So this is one of the connection options for a GPS. Now in this configuration, the Mercury is not aware of the GPS 3. So the Mercury cannot use this in conjunction with the gyro for speed compensation. So with this connection set up, the GPS simply provides GPS status information back to the transmitter. So let's go over to the transmitter and let's have a look at what we can see. Okay, we're now back looking at my core's main screen. You'll notice all the other remaining telemetry widgets have been removed. I just deleted them just so they don't get in the way. So let's make a new widget for this GPS. Again, into our telemetry menu. We have to rescan because I've changed the configuration without changing the model and back again, etc, etc. So let's rescan. We should be able to see our GPS 3 in the list, and there it is. Just comes up under GPS 3. And there's a whole lot of parameters. We can measure altitude, speed, 2D distance, 3D distance, the overall trip, what current heading it has, satellite count, accuracy, longitude, latitude, and status. Now, because I'm in my garage and my garage is basically a Faraday cage, the GPS will not work inside my garage. So let's just look at status. And again, we can have a look at its address, except in this case, we don't really need to, but you'll notice its default address is 40. And you'll notice it says searching for satellites. So that'll stay there searching for satellites all day long. So, for instance, in this configuration where we've connected it to straight directly to the P2 bus, you notice the GPS came up in the sensor list. So again, if we have a look in the overall list for sensors, the GPS of 3 appears in the sensor list. That's because it's connected directly to the P2 bus line. Later on, when we connect it to the fast track port of the Mercury, it will not appear in this list. So no matter how many times we rescan the bus or whatever, it just will not appear. So let's delete this. So let's just remove the widget and let's connect it to the fast track bus on the fast track port on the Mercury SR2. Okay, back to viewing our fancy model here. Let's switch it off. So you'll notice the green light's flashing on the GPS because it's not seeing any satellites. However, let's switch it off. Let's disconnect it from the P2 bus connection. And this time what we're going to do is we're going to connect it directly into the Mercury's fast track port. If I can reach around the camera and plug it in. There we go. So it's plugged into fast track. So normally we would have a gyro plugged into the same port. However, for this example, we just need the GPS plugged into that port to show you how it appears on the core screen. So again, let's switch it on. System's on. Notice we've got solid green lights on the 2 receivers and a flashing green indicating it's looking for satellites on the GPS. Okay, let's move over to the core screen. Okay, we're now back looking at the screen on my core transmitter. And remember I deleted the widget for the original GPS 3 connection, which was via the P2 bus. So let's make a widget. So make a new widget. And we go into the sensor list and you'll notice there's a GPS 3 in there. And that's because I haven't rescanned the sensors and it thinks there's a GPS 3 in there because it hasn't done an update or hasn't rescanned the bus. So let's see what happens when we rescan the bus. So remember that GPS 3 was in there from when we previously set up the GPS on the P2 bus connection. So let's rescan sensors and let's see what happens now. So normally this would occur when you first turn on your core and load that model. It will automatically rescan the sensors. However, because I've left the core on, and you'll notice now in our sensor list, the GPS 3 has disappeared. And that's because it went out, looked for it. However, there is no GPS 3 now connected to the P2 bus line. So it's disappeared. So this is where people get a little bit confused and they say, oh, I've plugged in my GPS into the Mercury. I can't see my GPS. Where's the GPS information? Well, remember that we've plugged it into the fast track port of the Mercury. So basically all the telemetry information from the GPS or all the data from the GPS is processed through the Mercury. So to access that information, we now need to go into the Mercury and have a look inside the Mercury's menu. So let's have a look inside the Mercury's menu. And you'll notice we have the standard parameters like the 2 battery voltages, the regulated output voltage, the capacity calculation, the current from the 2 batteries, antenna fades, loss frames, holds. And then as we get down to here, we'll notice there's speed, altitude and distance 2D, etc., etc. Trip, accuracy, heading, long lat. So those parameters pertain to the GPS itself. So for instance, if we click on speed, bring up speed, obviously it's going to be 0 because we've got no satellites. We're now looking at the speed that's calculated by the GPS through the Mercury. So you notice basically the information is coming from the Mercury and not directly from the GPS. So the system is accessing the GPS data through the Mercury. So it's just something to be aware of, because a lot of people get confused about this, and they're looking for GPS information and they can't find it yet. It's all in there. It's just within the actual Mercury itself. Cool, simple as that. And I think that'll be the end of this video, and yeah, hopefully you've learnt a little bit about setting up telemetry sensors. And again, the major point of this video was interconnection of the actual sensors, not so much programming alarms and that. I've done another video on that. It was just more so how to basically connect the wires to them, and a little hints and tips on what to look out for. So hopefully you've enjoyed this video. It's a bit of a longer video, but hopefully you've enjoyed it. And yeah, look forward to the next video. So the next couple of videos, I'll be focusing on the Mercury SR2 itself, and we'll delve into the programming, setup, etc., of the actual Mercury unit. Until then, take care, and we'll catch you on the next video. Thanks to all for watching.